Welcome to Unsolved. Today's LeetCode Daily challenge is maximum distance between points on a square. You are given an integer side representing the edge length of the square with corners 0, 0, 0 side, side 0 and side on the Cartesian plane. You are also given a positive integer k and a 2D integer array points where points of I equal to xi comma yi represents the coordinate of point lying on the boundary of the squares, and you need to select k elements along points such that the minimum Manhattan distance between two points is maximized, and return the maximum possible minimum Manhattan distance between the selected k points. The Manhattan distance between two cells xi yi and xj yj is xi minus xj plus yi minus yj. So the question says that we have to find minimum out of the maximum. So this problem can be solved. This type of problems are easily solved with the help of binary search. So the idea is, let's take this example. Side is equal to 2, so the side of a square is 2, and we have given points. These points lies on the boundary of the square, so we have to select from that points. We have to select only 4 points, means k point, and in such a way that the minimum Manhattan distance between every 2 points from the any point should be maximum. Okay, so how we can solve this? So let me show you something. So if this is a square, and so the perimeter of the square is 4a, this is a simple formula, and the area of a square is a square. Okay, so how to write the code? So for that we will convert this square into a linear line, and we will calculate the position of the point. Okay, so for that we will take array to store the positions. So take a array, and after that iterate through the points. For every point x comma y in points, what we will find, we will check the condition. If x equal to 0, then our position will y, and if y equal to side, then position will side plus x. If x equal to side, position would be 3 into side minus y, else position would be 4 into side minus x. And finally we will append for every time, and in every time we will append the position into array. The position array dot append position. Okay, and we will sort the position because we want to apply the binary search. So binary search would work only the sorted array. So sort the array, and after that we will apply the binary search. For that we have to find the minimum and maximum limit. So our minimum limit low is equal to 1 and high equal to what would be the maximum distance? The side of the one square can be maximum, so we can take high equal to side, and take an answer which initializes with 0, while low is less than equal to high. We have seen the binary search code. It is simple, and we have to find the mid of. How to find mid? Low plus high by 2 is the mid, and if we will check it is possible to take the mid, and that we can select the k points by taking this mid. If the condition is true, then we will go for the next low will incremented equal to mid plus 1 and answer equal to mid. Otherwise the high equal to mid minus 1, and finally we will return the answer. Okay, so we will check can make at least mid. So mid is the limit. Okay, so for that we have to write the function check. So we are going to write the function check, which I have used to check the limit. So what is this limit? The limit is a value that is a maximum value that can be we can select the k points. So for that we will calculate the perimeter. So the perimeter equal to side into 4. So the square perimeter of a square is equal to side into 4, and for every point we will check one by one it is possible to take this limit. So for that, for start in ARR, we will take every start from the ARR, and we will find the 2 point. Our current point would be the start, and our end point, for because the square is a connected part, so we will try to wrap around it. So for that, start plus perimeter minus limit, and after that we will check every other points for hyphen in range k minus 1. So we have taken first point as a start, and for every k minus points, other k points point, we will check the index using the binary search bisect left. This will check whether it is possible to take from this ARR. We will check the current plus limit. Current is our start point, and after that after getting the index, we will check is this index is valid. For that I will check the boundary limits. If index is equal to length of the array, the second condition is, or the array of I, is it in the boundary or out of the boundary. For that we will check array of index is greater than end, and if the condition is not true, means this condition is true, then we cannot take this array, this we cannot continue with this start. So we will mark it -1 as it is invalid and break the loop here, and after that we will initialize current. If the condition is true, then we will that means limit is possible, then we will initialize or update our current with array of index. We will update our current, and after updating the current we will check if whether finally we will check our current is possible or not. That means it is not marked as -1. We will check it is greater than equal to 0, then we can return true, otherwise return false. So in this way we can check. So try to run it. List index out of range. Let me check it. So I think the current must be updated for every index. So for every value we will update the current. Let me check it now. It's too slow. run it again. Yeah, it is now accepted. So try to submit this. Okay, it is accepted all the cases. And I want to show you something that what is the complexity. So for sorting we have taken and log in the binary search log of side, and for each k points we have checked k into log n. So the complexity is log n. Okay, so the problem was looks like a geometry but is actual binary search plus greedy problem, and we will convert the square into parameter position, so this problem become manageable. Okay, so thank you, see you tomorrow, bye bye.